Yes, Assalamualaikum warahmatullahi wabarakatuh. Today we are going to discuss about a methods that we can use to prove a mathematical statement, or maybe a theorem also. We can prove it by using what we call mathematical induction. So we write it down, mathematical induction. Okay, now to prove by this method, we have to do two steps. Okay, we call it step one. Step one. So in step one, what we have to do is we have to show that P1 is true. Now this number 1 is arbitrary. Maybe 1 or maybe some other numbers, maybe 0 or maybe some other number. For example, if the domain is n is greater than or equal to 3, okay, that number is not 1 but 3. For step number 2, okay, what we have to do is we have to assume PK is true. Assume PK is true. Then we have to show that PK plus 1 is true. Okay. That's basically what we have to do in proving by using mathematical induction. Some books or some authors, they write for step 1 as basic step. Basic step. For step 2, they call it intuitive step. Inductive step. Like this. Okay, that's basically what we call the process that we have to go through in proving by using mathematical induction. Now, let's say we are given this mathematical statement like this, okay, in which we have 1 multiplied by 1 factorial plus n, that is 2 multiplied by 2 factorial plus dot 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 plus n multiplied by n factorial equal to n plus 1 factorial minus 1, where n is, well, let me explain here, n is a positive integer. Positive integer. Like this. So how to prove this? By using mathematical induction. Yes, we have to follow our steps. Okay, let's prove it. Okay, now before we go to step number 1, we have to let first. Let PK equal to this statement, like this statement, but whenever we see n, we replace by k. So what we have is 1 multiplied by 1 factorial plus 2 multiplied by 2 factorial plus up to k multiplied by k k multiplied by k factorial. That is k multiplied by k factorial equal to what? K plus 1 factorial minus 1, like this. Okay, now let's check for step number 1. Step number 1. Now for the left hand side, we have what? Whenever we see k, we replace by 1. So we have 1 multiplied by 1 factorial equal to 1 factorial is equal to 1. So this is 1 multiplied by 1 is equal to 1. For right hand side, we have k plus 1, that is 1 plus 1 factorial, then minus 1. This is equal to 2 factorial in the bracket, then minus 1. And 2 factorial is equal to 2, 2 minus 1, this is equal to 1 also. So we see here, we have left hand side equal to right hand side. Therefore, P1 is true. P1 is true. Okay, we are done with the first step. Yeah, now let's continue with step number 2. Step 2, yes. Now in step number 2, as we mentioned earlier, we have to assume first. Assume PK is true. Tu dia. Yes. We want to continue with yeah, we are looking for pk plus 1. Yes, pk plus 1 is equal to what? Yes. So 1 multiplied by 1 factorial plus 2 multiplied by 2 factorial plus dot plus we have k multiplied by k factorial. Now we have to add one more term, right? Yeah, k plus 1 term. That is k plus 1. Yeah, multiplied by k plus 1 factorial, like this. Now, if we notice, or if we look carefully here, this term up to this term is just pk. So we can replace that one by pk that we just write a few minutes ago. That is k plus 1 factorial minus 1 plus this term. It is plus k plus 1 multiplied by k plus 1 factorial. Now, up to this stage, we have to manipulate this algebraic expression, okay, until we get, or we reach our target. What we mean by our target is like this. Okay, if pk, okay, the right hand side, we have k plus 1 factorial minus 1. If pk is like that, so our pk plus 1, okay, supposed to be, whenever we see k, we substitute by k plus 1. So k plus 1 plus 1, that will be k plus 2 factorial minus 1. Now, whatever we do in this step, okay, our target will be, we try to get this expression here. So let's see whether we can do that. Equal to, I think we better rewrite this term, change it, move it around. So we have k plus 1 multiplied by k plus 1 factorial, this term. And then we add this one, plus k plus 1 factorial. Okay, then with minus 1. Now, from these two expression here, we have k plus 1 there, factorial, and also we have k plus 1 factorial here, k plus 1 factorial here. So maybe we can factorize that. So equal to k plus 1 factorial. Then we have this big bracket here. What's we left there is k plus 1. From that, after you factorize k plus 1 factorial, what's left is this term, k plus 1. From this term, after you take out k plus 1 factorial, you're left with 1, right? And minus 1 there. So what we have is k plus 1 factorial multiplied by, okay, let's simplify this one. You have k plus 2. K plus 2, okay, and then you have minus 1. Now, if you look at these two terms carefully, you will see k plus 1 factorial multiplied by k plus 2. That's the same as k plus 2 factorial. This one. This is the same as k plus 2 factorial minus 1. And that's exactly what we are looking for. That is pk plus 1 is k plus 2 factorial minus 1. Thus, what we have shown is p of k plus 1 is true. So the what we call the proof is complete. Okay, thank you.